Okay, I'll get started. If you have questions, there are mics, one here, two up here. Please pass it back. Thanks for coming here. Good afternoon. I'm Saravana Kannan from the Android Common Kernel team at Google. So since I work on the Common Kernel, our stuff kind of works across all the devices at Google. So the Pixel phones, Pixel watches. So I kind of get to work with all of them. One of the common themes across all these devices is, hey, suspend resume latency is pretty high. I mean, pretty high. 100 milliseconds is pretty high for them. So from end user perspective, resume latencies have a user experience delay. So if you hit the power button, if it takes a while for the screen to render the first frame, that's a bad user experience. From suspending latency, the problem there is for devices with small batteries. Every extra time you spend auto suspend is battery wasted, and that kind of adds up, surprisingly. So before I go into, by the way, I'm not necessarily providing solutions for everything, just pointing out the key issues and maybe potential solutions for some of them. And this is meant to be like an open discussion, so feel free to interrupt and ask questions. If I time myself correctly, I should be done in 20 minutes, so we have plenty of time. So before I jump into it, some key phases of suspend resume, going by what the trace points tell, right? So during suspend, you have a suspend interface that has two sub-phases called sync file systems and freeze processes. And then you suspend all the devices using the different DPM calls: prepare, suspend, suspend late, no IRQ. And then you eventually power off the CPUs and put the system into suspend. In resume, you do the reverse. You power up the CPUs, resume no IRQ early, resume complete, and then you thaw all the processes. So let's kind of dive into each of these phases to see what's bad and what can be done, or at least highlighting the issues. So if you look at optimizing suspend resume, today we sync the file systems for every suspend. Every time you enter suspend, you synchronize it. On a device where you go in and out of suspend multiple times and very frequently, is it something that's worth doing is a question to ask. On some devices, it doesn't make sense. So we do choose to disable sync on suspend. Another part of this is that the VM subsystem already has ways to flush out dirty pages. So you don't necessarily need to sync on every suspend because you have that kind of covering for you. But one of the caveats of that is it doesn't go by wall clock time. It goes by time you spend out of suspend. So any time you spend in suspend is not counted as the age of a page. So you have dirty expire syntax that gives the maximum age of a page. And then dirty write back syntax is how often the kworker thread wakes up to check the pages and flush it out. So that's something you can tune. So for example, on a watch, we disable sync on suspend, and we have tuned that sufficiently enough. We're confident enough it's good enough for a watch. It might not be the same for a phone, so that's something to think about. And so yeah, solution is disable sync on suspend using syspower sync on suspend tunable. I guess question to the community here is, should we be making these VM tunables to take into account time spent in suspend? Because I'm guessing when they were implemented, they were thinking more of a laptop where you open it up, work on it, dirty pages get flushed, and then you close the laptop. You're not going in and out of suspend as often. So in those cases, this behavior kind of matched real wall clock time, because once you suspend, you really aren't looking to wake up and have dirty pages to flush out again. So if somebody's more familiar with this or interested in this, that's something to look into. Just to kind of, what happened here? Yeah, to kind of make it a little bit more robust. Oh, and other point I called out here is syncing takes 30 to 66 milliseconds. That's 10 to 35% of the suspend latency. So that's pretty high. Going into freeze process, I was actually not planning on covering this because I'm like, you have to freeze the processes and you can't do anything about it. But then I was looking at by the way, this is a Perfetto, if in case you don't know what that is. It's a trace viewing tool. It's ui.perfetto.dev. You can load up any kernel left trace and it'll try to show it in a visual form. It's pretty handy, super helpful. So anyway, so the green stuff you see there is the freeze process. And out of that, half the time, CPUs aren't really doing anything, most of the CPUs. Just like one CPU doing some work. Is all of that really just freezing processes? I'm not fully sure. Seems a little unlikely. So that's something we should look at it as a community. And I've seen issues of weird behavior here where if you have work queued, and if the worker thread or whatever is freezable or not freezable, depending on that, you can have some weird behavior where it'll wait around to finish all your work before you can cross this barrier in some sense. So my guess is some driver is doing something weird here is my guess. I'll need to take a closer look at it. But in general, even if the driver is doing something weird, should we be having this behavior, something to figure out? Going into a part of the suspend resume I'm a little bit more familiar with, device suspend resume. So let's look at what resume looks like, right? So this is the entire resume stages. I don't, it's kind of blurry here, I think, the focus. But the idea here is that that whole thing is resume, all the stages combined. And as you can see, most of the CPUs aren't doing anything, mostly idle most of the time. But you're running through all the suspend, all the resume phases here. But we do have asynchronous suspend resume in the kernel. I'm not sure how often it's used. So we went ahead and said, OK, let's enable it for all the devices in the system. And surprisingly enough, it actually worked. So that was a little bit of a surprise, a pleasant surprise, I guess. So I'm assuming firmware debugging, tracking all the dependencies here is kind of helping with that. So that's one good thing to know. You can try async suspend. But if you see here, it works, but actually makes things worse. So it used to be 82 milliseconds, but if you do things asynchronously, it's 102 milliseconds. Yay, 20 milliseconds worse. Now let's look at suspend. This is again suspend, normal, no optimizations. Again, system is mostly idle, sitting around doing nothing. Like, if you can see, like, lots of time in there where all CPUs are idle, completely wasted time. And it takes 126 milliseconds here. Again, if you enable async for all of them, thankfully in this case it's getting better from 126 or something to 94 milliseconds. So that's 32 milliseconds better, but you still see a lot of idle time in the CPUs. And ironically here, if you look at the kernel code for suspend and resume, the suspend code tries to be less asynchronous in how they implement asynchronous suspend, and that's actually helping. That's why it's not worse. And if you try to do like super asynchronous, like the resume code does, then it actually gets worse. So why is asynchronous suspend resume hurting or not helping as much as we want to? So the only real answer here could be that you have more overhead trying to do this when you're trying to do asynchronous suspend resume. And my guess here is it's all the k-worker wakeups, context switches, maybe work queuing. That's taking a lot of overhead. There's also a lot of wait for completion, where a device will wait for its parents, children, or consumers and suppliers to finish whatever operation they're doing before it can run its own operation, depending on whether you're talking about suspend phase or resume phase. They wait for different parts of the dependency tree. And a lot of the devices have no ops implemented at all, or they're like really quick. They take like a few microseconds. So doing all this overhead of the asynchronous suspend resume isn't really great for them. And overall, asynchronous ends up being more expensive than synchronous suspend resume for these devices. And then one potential proposal is to say, hey, can we just do asynchronous only for the slow devices? And we can have, we actually kind of do this manually today in some of the devices, and it actually helps, where suspend gets better, but resume doesn't get worse, because we only enable asynchronous suspend for some of the devices. The idea we do there is we take the worst offenders, and then we set async flag for that device and all the consumers and all the suppliers of the device. So if you think of the device in the middle, it's like a tree exploding in each direction. So you need to set the flag also for the consumers and consumers of those consumers, and you have to set the flag for suppliers and suppliers of the suppliers. But you don't need to set it for consumers of suppliers or suppliers of consumers. I know it's a huge word salad, but the idea is like if you take the device in the middle, each direction, it's kind of like an explosion of dependencies. So for example, the reason we need to do that is that's actually the typo there. It should be 3B and 3C. But we need to set these flags for these consumers and suppliers because you might have an asynchronous device that's slow, but it's going to wait, let's say, for, I don't know, 100 milliseconds, because one of its consumers is deep inside the suspend resume list. So until that synchronous consumer finishes, you can't continue with the asynchronous suspend resume. So the idea is to set all the consumers and all the suppliers to be asynchronous so that you get to run those asynchronously too. You might have an additional overhead in running them asynchronously, but you make up for it by running the really slow thread asynchronously too. And then you leave the rest of them alone. So the consensus here is that when you do this, you still end up setting, asynchronous flag for some of these quick devices, and you have overhead there that you're kind of wasting time. And the other thing is it doesn't parallelize as much as you can, again. It's just kind of getting you halfway in there. The other proposal is what I call breadth first, bottom up. So if you think of it as a dependency tree, and if you think of it as, like, say, suspend as an example, the idea is to basically have one thread running on every CPU that just suspend the leaf nodes. As you suspend the leaf nodes, you create more leaf nodes because now all the leaf nodes are suspended. And then you go back and kind of keep looping until you just suspend all the leaf nodes. So you basically bottom up the dependency tree, you're suspending all the leaf nodes and going up. In reality, it's an acyclic dependency graph, but the idea is still the same. So instead of saying, hey, go to everything in this order, synchronous, we have like a synchronous DPM list is I think what it's called. It's basically a list of devices where it's kind of sorted, where you'll never suspend them in the wrong order if you just follow that order. So today for asynchronous suspend, we still kind of follow that order, and then we shoot off asynchronous threads wherever we can. Instead, it might be better to just have n threads that just take care of the leaves. So that would avoid the overhead of work queuing, k-worker wakeups, context switches. Then there won't be any wait for completion because you only kick off things that are ready to suspend already. So that's something I'm thinking of trying out. I might still end up using work queues here for this, just to not change too much and not be invasive. But I think I can still manage to avoid sleeps and context switches as much as possible. You might end up in a case where there's only literally one leaf that you can suspend. And in that case, you're going to have only one CPU doing something. But the idea is to still try to do as much parallelly as you can. So the question here is, am I missing anything here? Any caveats I should be aware of if people have thought about this or tried it before? Another way to optimize suspend resume is a lazy resume and early suspend using runtime PM. Pretty sure most of you know, but just to kind of give a brief overview, runtime PM is runtime power management. You can suspend your device while the system is out of suspend. You can still suspend your device if it's not being used. How we define it's not being used is kind of left to the driver, if I understand it correctly. And the idea with lazy resume is if you're powering up the device and you're never going to, if you're going to resume the device, but you're never going to turn on the display, why would you need to resume the display or the display subsystem? That's a waste of time. You could just leave them suspended, go do your thing, or maybe wake them up later. The idea behind all of this is to get to user space as fast as you can, because that's where the real work is getting done. Similarly, why would you want to serialize resuming your storage if you're trying to render a frame as quickly as you can? So when you hit the power button, storage, depending on the device, it takes from 50 to 100 milliseconds to resume. And now you're not rendering a frame for that much longer. So if you have every info that you need to render the frame already in RAM, maybe you can do that in parallel. So runtime PM would help there if you enable runtime PM for that device. So that is what I call a lazy resume. And early suspend, so early suspend is, if you don't use the device, suspend ahead of time. So when you do choose to suspend the system, that's one less device to worry about. Firmware doubling equals RPM is the default config in the upstream kernel now, which basically means firmware doubling enforces runtime PM dependencies correctly. So it should be more stable, hopefully now. You don't have to worry about somebody not missing a dependency. So, I mean, as far as lazy resume is already supported. I looked into it, but it's not as prevalent as I would like it to be. A lot of driver developers don't even seem to be implementing runtime PM. So the question is, can we do something to make it easier? As a community, what can we do to make it easier for driver developers? I think that's something to think about it from all the framework perspective too. And then last but not the least is turning off the CPUs. Oh, okay, question here, finally. You wanna?
Can you hear me? Okay.
Yeah.
So in lazy resume path, you said you would resume only devices that actually matter.
Yeah.
Right? So who would actually decide that? Where do you get that information from?
Yeah, that's a good question. I think it might be, depending on system, you have to configure that way. Right?
I mean
Also, technically, if you enable runtime suspend or resume for everything, let's say theoretically, right? Every device implements runtime suspend.
Yes.
Sorry, runtime PM.
Yeah.
Then you can just go straight to user space, and first time they start using the device, you can start resuming them.
So the devices which are already suspended,
right,
using runtime suspend.
Right. So let's say system is fully in suspend. You're waking up. You effectively skip the entire DPM phase, and go right to thawing processes.
Yes.
And say when you start asking, requesting to read from the disk the first time, that's when you kick off the resume, and then you honor the request.
Okay. So you start with nothing.
Right. That's an extreme example. That's one option to do.
Okay.
If you have comments, there's a question back there.
What about the devices that just run in the background, like a display, for example? So it has runtime PM suspend, but at the same time, we really want for it to be up when.
Did you say display?
Yeah, display.
But here's the thing, though, right? If you resume, let's say part of the normal resume, you're still taking the same amount of time to resume. You're just not letting the rest of the threads run, right? So if you skip, let's say you skip entire DPM phase and you go to thawing processes, the process is going to say, hey, let me try to render a frame, or let me turn on the display. That's going to trigger the runtime PM to resume it.
But who triggers the runtime resume if we just have a user space having a static picture on the display?
I think that's what I was saying. It kind of is going to be defined by a driver-specific way, right? So, for example, when somebody's trying to turn on, when you get a command to the display driver, and if you haven't resumed,
Who's going to give the command?
how does it work today? How do you get to the display driver to display?
It just runs. Well, I mean,
No, it's not. It's still getting some op is getting called, right?
No.
It's not like no op is getting called inside a driver. It's still getting into the driver to trigger and actually manipulate the hardware.
No, it just has a frame buffer set. There are no additional calls from the user space. There are no additional interrupts from VBlanks. We do not care about them. So really, just no interrupt in case of a single image.
When the screen powers on for the first time, you're saying there's nothing talking to the driver to turn on the display? I'm pretty sure.
After the suspend. Okay. Let's discuss.
But the thing is, it's still something for you guys to figure out. I'm not claiming to be an expert on this, right? But that's the kind of the idea overall. Masa? Yeah.
Using the runtime PM, if you don't have anything special to be done during system suspend and system resume, it's just that, you don't have anything to do. And once the driver will be kicked by someone to do something, then it will resume the device, and that's it.
Right. So
But
the current support.
It's only if you need to do something more during system suspend, then you still need to keep system resume.
That's what early suspend is.
Yeah.
I guess the question coming from them is, how do you know when to turn on?
So again, you are relying on the runtime PM to do most of the stuff, right? But you're relying on runtime PM to do most of the stuff or the information from there, right? But the devices might not be in a low power state, in a very low power state in runtime PM callbacks, because they wanted to get back to work quickly as possible.
That's actually a good point you bring up. So, for example, a lot of devices might choose storage is a good example.
Yeah.
They have a runtime suspend some of the storage devices, but they go to like partial off state, not fully off state.
They're not fully
because coming out of that is going to take 90 milliseconds.
Yes, they want to
just like normal resume. So they don't do that. So maybe that's something. Maybe Wolf, we need to think about to see if do we need stages of runtime suspend.
So what we've done for MMC, this is very long time ago we did this work. But what we do is that we power off the MMC device when we do suspend. But when we resume, we do not power it back on. We're actually waiting for some request coming in from the block layer to actually read something or write something to the MMC. It's only at that point when we.
I don't know enough about this, but how does it translate to UFS?
So this is only for eMMC. So this is an
okay.
eMMC or a MMC subsystem specific
Okay.
implementation, but it's doing exactly the same thing that you're talking about.
Yeah,
so
but maybe we should make it more generic somehow. I don't know.
So I don't think it's easy to do it generic because. As in the graphics.
Like on the block layer, for example, say,
So the
kick and say, hey, I'm going to use you.
Yes,
Make sure you're up.
there is some implementations for runtime PM in the block layer, but I think you will need to go into the block device specific part of it because eMMC is a specific device that you need to manage in a specific way to power off and power on. So.
No, just triggering it, right? Obviously, the drivers is going to implement because it looks like based on at least questions here, everybody's like trying to figure out when do you resume, runtime resume, right?
So
that's what we need to make it easier to do.
So for easier devices, we have these helper functions that's called force, PM runtime force suspend and force resume. They are taking all these things into account.
So which devices?
PM easier devices.
Okay.
I mean less complicated devices that might just do a register, read or write or something like that during suspend resume. But the point is that you can use these helper functions, and it actually leaves the device in runtime suspended state when you do system resume, and it's waiting until there is a actual request coming in for the device. So. If you use these helpers, you get all these things.
Yeah, maybe
for free.
part of it is somehow we should try to educate the community more. Because even it took me a while for me to understand what the heck was going on.
I've tried to educate people about this for many, many years. It's been a while since I actually, promoted this.
Yeah, I see the hands up. You can put it down. I'll send it to you.
Yeah.
So just to finish responding to the comment there, there's also the DPM prepare and complete. Suspend, prepare, and resume complete, I think, where just think of it as an educating the community here. If you return a particular value, I think non-zero, positive, then it basically tells the kernel, hey, I'm already in a powered off state. Next time you can jump directly to complete. You don't need to go through any other stages in between. That's apparently a feature.
I wouldn't recommend using that.
Okay, great. In case you guys didn't hear, Ulf was saying he doesn't recommend using that.
There's other methods.
Which one?
There's other methods to do
Okay.
similar thing. So primarily there's two ways.
Can we pull it off on discoverable buses like USB or PCI?
Sorry, can we pull up what?
Can we pull off this strategy?
This has nothing to do, yeah, buses shouldn't matter here at all. Like if you take I2C as an example, you can do that there too. It's about the driver saying, hey, I can.
On I2C, we tend to know that the device is here over device tree or ACPI, but on PCIe, the user may pull out the card or put it in at runtime, and the host is generally suspended on.
How is it different from suspend, right? That has to work for suspend too, whether you do it runtime suspend or normal suspend. Pulling out a device is going to be an issue either way.
Okay, but let's say that we have a GPU in the PCIe slots and we suspend the PCIe controller so the GPU is no longer visible.
Firmware developing will ensure you cannot suspend, runtime suspend the PCIe before you runtime suspend the GPU.
Okay, but if we suspend the controller, it may drop the device list, and then we can no longer reference the DRM device to wake it up again.
Okay, but you wouldn't want to do that, right? You wanted to suspend the device first before you suspend the PCIe controller. I'm not sure I'm understanding your question there.
There's at least one platform upstream right now which actually drops the devices at PCIe controller suspend, I believe.
Okay. I don't know the answer to your question. I'm not even fully sure I understand your question. If anybody else can answer,
we can talk after.
Yeah, we can take it offline. What's your name, by the way?
Mine? Konrad.
Cool.
I think the question is that when you're suspending, so your GPU PCIe device will be suspended and removed from the list. So when you're resuming, because you're not sure that the card will be there, you must first resume your PCIe host to see if there is anything else still connected. That's your point? Yeah.
How does it work today for suspend resume?
Sorry?
How does it work today for normal suspend resume?
I think that the point is just that when you're suspending, you're removing all the device connected, assuming they might disappear at resume.
Okay.
So is the logical conclusion to all this work that you would continue with S2 idle and then eventually you sort of...
Oh, actually, oh wait, I haven't even talked about S2 idle. Maybe I'll move on to that. People are walking away already. Sorry. Yeah, I'm hitting it, yeah, already out of time. But last part, the most important part, turning off the CPUs. There's S2 RAM, where you hot plug out the CPUs, and S2 idle, where you idle power collapse them. Huge improvement. For sure you want it, and we know it works. But unfortunately, it's only true if the firmware is not buggy, and the firmware supports the S2 idle specific PSCI calls. And getting already existing devices to add support or fix the bug is next to impossible. And even now, people are making chips without S2 idle support. So my question here is kind of looking at Wolf here. Can we implement something like S2 idle, but using the S2 RAM PCI calls, where you kind of hide it underneath a shim or another C state, where you fake it saying, when you're trying to go to idle, just call the hot plug APIs to power off the CPU. And then when you're trying to wake it up out of C state, before you send an IPA to wake it up, power back up on. That's something I seriously want us to look into. I'll try to work with Wolf on that. But it's been a headache trying to get S2 idle working on some device, and I kind of given up hope on it. I'm like, these devices are only going to do S2 idle-like behavior. We have the shim layer around S2 RAM hot plug APIs. That's my personal take on that. So that's again question to, hey, can we do that? Should we do that? Yeah.
So yeah, we are going to look at that. I don't know if what you're proposing is the solution.
Yeah,
But yeah,
something
that's
along
part
those
of our
lines.
that's plan that we'll look at that, how to make a suspend to idle to work on
Yeah.
even legacy platform.
Happy to test it with broken
Yeah.
devices.
Yeah. But
Yeah.
I agree that suspend to idle is the way to move compared to suspend to run.
Yeah. And again, as number of CPUs increase, it just gets worse and worse.
Do you have any numbers, duration that you can share about
No.
how much you save? No.
But I think I think resume is not bad, which is where people care more about than suspend, because hot plugging on a CPU is pretty quick, but suspending is where it has a huge impact, because you have to migrate, and inefficiently, it's like an N square kind of behavior almost.
Yeah, I would be, and that's probably also depend of your.
Can you hold the mic?
Yeah, that also probably depend of the size of the RAM that you have and how much you have to initialize. When you're plugging back the CPU, you have to initialize a lot of things around the CPU, and that can take some time.
Okay.
It'll be
But yeah, I think it's in the order of like, I'm just ballparking from what I remember, like 50 milliseconds is how much you save. That's still a huge amount. But
15
50
per CPU or 15
total for
total?
suspend.
Okay.
Yeah. That's all. Thank you for asking the questions and keeping it interesting.
Yeah, so sorry, I wanted to ask basically...
Done, but now I can wait for questions.
Oh,
Go
sorry. If you are able to sort of suspend all of the hardware peripherals, all the devices, disregarding entirely the full system suspend resume cycle, then what is the battery life advantage to actually doing S2 idle over just using like C groups, for example, to freeze all of the processes and user space?
That's a good question. We can definitely look into that after we
Right.
get to all devices. But no, it's a really good question. I think it would make
do
it
you
even
think
better.
it would be significant, or do you think it would be?
I think it
actually
really
makes
depends
sense to-
on
You
one
need to
second.
suspend some regular wake up. If you're only freezing your process, you still have some background activity waking up periodically. All
With
of the-
S2 idle, yes, but I've been talking to people working on the Linux mobile side of things, and they are much more interested in runtime PM and want to just kind of avoid suspend entirely because it comes with a lot of complexity and risks. And if we just freeze all the user space processes but don't actually enter S2 idle at all, how much battery life do we really lose there?
So the main difficulty is there is in order to reach this low power state where you want to put the RAM in a self-refresh, you want to make sure that all the no device will access to the memory at any time. With system suspend, you're sure that all the device has been suspended, so you can reach.
No, but
If you want to do that at
With,
runtime,
if you runtime
This question is still valid, right? If you do runtime PM4 and it happens to be all the devices are suspended,
yeah, but
do
you
we
have-
really need to do suspend?
then you get opportunistic suspends
Yeah.
yes,
much more.
that's the next step. But you have to make sure that all the devices are
Right,
using
right.
runtime PM and that you are not forgetting any kind of dependency. But yeah, I agree. That will be the next step.
You would get opportunistic suspend without actually having to trigger a system suspend at
Yeah.
all. It would
As long
just-
as user space is behaving correctly and no crazy wake up interrupts, yeah, we should be able to. And I don't want to get into the details of it, but that kind of is useful for other scenarios too. Maybe that's what we're talking about, where if we can suspend the Linux system, kind of.
So I would say that there's one problem with that is today we could actually treat those different states as, I mean, system suspend can be one state on a per device level, and the runtime state can be a different state. It can be, I mean, deeper or shallower state.
Yeah.
So that's another problem.
Yeah.
If you have different states for a device.
Yeah.
What,
By the way,
what,
like
what,
if,
can- what
if
should
I
you
understand
do?
correctly, runtime PM doesn't have different levels, right? You just
It's-
suspend it.
it's just one level.
Okay. Yeah. So all the devices have to support the deepest suspend state in the runtime PM.
And you might not.
Then we can do
Yeah.
this. Yeah. Lots of ifs and buts,
Yeah.
but we'll get there hopefully. Cool. Thanks, guys.